In this video, we're going to talk about how to solve inequalities. So this is when you have the less than or equals, the greater than or equals, the less than or the greater than symbols. Before we do that though, we're going to talk about interval notation, because when you're solving inequalities, you often want to give your answer using interval notation. So let's just look at this first interval. So the square brackets means that you include that endpoint. A round bracket means that you do not include that endpoint. So if you wanted to draw this on a number line, okay, so this arrow thing is our number line, this interval would go from 1 to 5, and I fill in the endpoints because they're included. Okay, and it's all of that area there. The next interval does not include the endpoints, so what we do is we just put an open circle. Okay, but everything in between is filled in. Okay, so the open circle indicates that that point is not in the interval. I'm going to skip 1 to 5, for you can try that one. From 2 to infinity, but we're not including 2, so maybe I should write the square bracket includes the endpoint. Round bracket does not. Okay, so here we have a round bracket around the 2, and then it goes all the way to infinity. So you would put the 2, oops, I want to open circle for the 2. Okay, but then it goes all the way until infinity. So you would color in the rest of the line here. So that's what that one would look like. And I'm going to leave the one below for you to try to make sure that we understand what's going on there. So when you're writing an interval, you want to be careful that the smaller number always goes first. Okay, so it doesn't make sense. Okay, if you write an interval like infinity to 2. Okay, because this is not the way the number line works. Okay, so here they're in the wrong order. Infinity is way bigger than 2. Okay, so you want to write them in the order that they would appear on the number line. And we never ever use square brackets for negative infinity or infinity. Okay, because these are not actual numbers. So you can never include it. Okay, you can never fully get there. So you can definitely not include that number. So some properties for inequalities. If A, B, and C are real numbers, and we have A less than B, then we know if we add or subtract C to both sides, that A plus C should be less than, B plus or minus C. Okay, as long as we do the same thing to both sides. If A is less than B and C is positive, then when we multiply by C, AC is going to be less than BC. So the inequality stays the same. So you can multiply by a positive number like we did before. But if C is a negative number, then you can still do it. So AC and BC, but you just have to flip the inequality. Okay, so if you multiply or divide by a negative number, then you have to flip the inequality. Also, if A is less than 0, then bigger than 0, then 1 over A is also bigger than 0. Okay, or similarly, if A is less than 0, then 1 over A is also less than 0. Or if you have even the other way, so 1 over A is less than 0, then A has to be less than 0. Okay, now this one is maybe a little bit less obvious. And in fact, we could write it for bigger than 0 as well. So if 1 over A is bigger than 0, then A is bigger than 0. And this you could also write more generally. So let's just talk about this one here. So if 1 over A is less than 0, okay, this is a fraction. So you know that it's positive or negative depending on whether or not the tops are positive or negative. And here, the top is definitely positive because it's 1. So that means that the only way this number is negative is if the bottom is negative. Because if you have a positive divided by a negative, you're going to get a negative. Okay, so that, and similarly for this one as well. Okay, division works the same, and also these are true for all inequalities. So we just use the less than or equal less than one, but they're all true for any of them. So you could replace less than with greater than, with less than or equal, or with greater than or equal. Okay, so we just did them for one, but they're true for all of them. So just a couple of notes. Only the direction of the inequality is flipped when you multiply and divide by a negative. But whether you don't change whether or not the equality is included. Okay, so for example, if x is less than 2 and we multiply both sides by -3, we change the inequality, but we don't add an equals. Okay, so it's still the same inequality, just flipped. And similarly, if y is less than or equal to 5, but we want to multiply by -6 on both sides, then we would flip the inequality. So instead of less than or equal, we have greater than or equal, but it still contains the equal. Now, one thing that's very important, maybe I should highlight some things here, is that we never multiply by an expression containing a variable. And the reason for that is that we don't know if it's positive or negative. So how do we know if we need to flip the inequality? Okay, so you want to be careful about that. So that's one thing that we can do for equations, but it's more difficult for inequalities. So let's try these two examples here. So I have 3x plus 4 is less than 5x minus 7. Okay, so I want to solve for x. So what I want to do is put x's on one side. So let's subtract 3x on both sides, because that's going to get rid of it on the left side. Okay, then I'm going to have 4 is less than 5x minus 3x is 2x minus 7. Okay, now I'm going to add 7 to both sides so that the x is by itself. Okay, that's going to give me 11 is less than 2x. And now I can divide both sides by 2. That's a positive number, so I don't have to flip the sign. And that gives me 11 over 2 is less than x. Or, if you want to rewrite it, x is bigger than 11 over 2. Okay, so remember that, all I did was change the order, but when you do that, you have to flip the sign, because all I thought about was, okay, so here's my inequality. The bigger side opens to the x. So I want to keep that same property. So I used to, people used to say that these things are like Pac-Man. Okay, Pac-Man always eats the bigger one. Okay, so I want to just maintain that he's eating the same one. Okay, so some people just like to read it this way, but this is fine. Okay, now we want to express our answer in interval notation. Okay, so in interval notation, we want all x's that are bigger, strictly bigger than 11 over 2. So I'm not going to include 11 over 2. So I use a round bracket. and I want to take everything bigger, so I want to go all the way to infinity. Okay, so that's what my interval notation would be. Okay, now let's try this one. So 1 over 1 minus 2x is less than 0. Okay, so it's 0 on the right-hand side. So I want to know basically where this number is negative. Okay, so again, you can use that rule that I wrote on the last page, but what you can think is 1 over 1 minus 2x is negative exactly when 1 minus 2x is negative, since the top, which is 1, is positive. Okay, so this thing is only negative when the bottom is negative. Okay, now you want to be careful that so it's tempting to multiply by both sides by 1 minus 2x. Okay, but we can't do that because we don't know if this number is positive or negative. Remember, we're not allowed to multiply by an expression containing a variable. Okay, but we can simplify this by noting that a fraction is only negative when one of the top and the bottom is negative. Okay, when they're both positive or both negative, then you're going to get a positive number. And now I have something that I can simplify. So I can move the 1 over to the other side by subtracting. That's going to give me negative 2x is less than negative 1. And now I want to divide by negative 2. Okay, so that means I have to flip. Okay, so that's going to give me x is bigger than negative 1 divided by negative 2 is positive 1/2. So again, in interval notation, I'm not including 1/2, but I want all x's that are bigger. So I'm going to go from 1/2 all the way to infinity. Okay, a compound inequality is a chain of inequalities. So you have multiple. If we're able to isolate the variable in the middle, then we can solve the inequality, and we can apply all of our operations to all sides at the same time. Okay, so just to make that more obvious, let's just do an example. So here's my compound inequality. So notice I have negative 5 is less than 3x minus 2, which is less than or equal to negative 1. Now you want your inequalities always going the same way, otherwise it doesn't make sense. Okay, so we want to solve this middle bit for x. So to do that, I'd want to add 2. So what I'm going to do is add 2 to all sides. Okay, so that means negative 5 plus 2 is negative 3. And then I just have 3x in the middle. And then negative 1 plus 2 is positive 1. Now I want to divide by 3 to get rid of this 3. It's a positive number, so I don't have to flip, but I divide everything by 3. Okay, so that's going to be negative 1 is less than x, which is less than or equal to 1/3. Okay, so that would be my solution. So then in interval notation, which is what it wants, which is what we normally want. Okay, we're going from negative 1 to 1/3. Okay, so it's going to look like that. But we don't include 1, but we do include 1/3. So we have a round bracket around negative 1 and a square bracket around 1/3. Okay, there's 2 more examples of compound inequalities. I'm going to leave those for you to try, and they will be solved in a future video.